she is one of mankind's oldest and best preserved ancestors and is more than 3 million years old. But new analysis of the fossilized arm bones of Lucy, an early hominin, suggests she was a tree climber. Researchers say that the relative strength of her arm bones would have placed her somewhere between a chimpanzee and a human, strengthening the evidence of our evolutionary path. Lucy's remains were uncovered in Ethiopia in the 1970s, with the 3.18-million-year-old skeleton being the most complete of any upright, walking human ancestor. Since her discovery, researchers have debated whether she spent her life in the trees or spent time walking on the plains as well. But the new evidence gleaned from scans of her arm bones proves she spent time climbing and used her arms to pull herself up, potentially ending the long-running debate among paleontologists. A team from Johns Hopkins University in Maryland and the University of Texas at Austin carried out fresh analysis of the fossils to reveal how Lucy moved and used her appendages. They used a library of thousands of CT scans of the fossils, created in 2008 and showing cross-sections of the mineralized bones. These were compared with cross-sections of humans and chimpanzees, which spend a mixture of time in trees and time walking on all fours on the ground. They found that the arm bones were more heavily built, similar to chimps, while her lower limbs would have meant she walked less efficiently than modern humans. Our analysis required well-preserved upper and lower limb bones from the same individual, something very rare in the fossil record, said Professor Christopher Ruff, a researcher in functional anatomy and evolution at Johns Hopkins. Our study is grounded in mechanical engineering theory about how objects can facilitate or resist bending, he added. But our results are intuitive because they depend on the sorts of things that we experience about objects, including body parts, in everyday life. If, for example, a tube or drinking straw has a thin wall, it bends easily, whereas a thick wall prevents bending. Bones are built similarly. Professor John Kappelman at University of Texas at Austin, who along with Professor Richard Kitchum created the digital archive of more than 35,000 carat slices in 2008, said, "It is a well-established fact that the skeleton responds to loads during life, adding bone to resist high forces and subtracting bone when forces are reduced." Tennis players are a nice example. Studies have shown that the cortical bone in the shaft of the racket arm is more heavily built up than that in the non-racket arm. A major issue in the debate over Lucy's tree climbing has been how to interpret skeletal features that might be simply leftovers from a more primitive ancestor that had relatively long arms. Professor Ruff believes the advantage of his study was that it focused on characteristics that reflect actual behavior during life, suggesting that even when Lucy walked upright, she may have done so less efficiently than modern humans, limiting her ability to walk long distances on the ground. Previous studies suggested that Lucy was just 4 feet tall and weighed just 65 pounds. Combining the new data paints a picture of an ancestor which may have spent a considerable amount of her time in trees. It also expands on evidence from earlier this year which claimed that Lucy may have died from a fall, most likely from a tree. Taken together, the evidence suggests Lucy may have been spent time on the ground, returning to the safety of the trees for food and to sleep to avoid predators. Professor Kappelman said she moved on the ground and climbed in trees, nesting and foraging there until her life was likely cut short by a fall, probably out of a tree.